Genius movie ideas aside, let's do another homework problem. In problem 6 from 2.2, we're told that the terminal side of theta passes through the point negative b, negative 1/2 b, where b is positive. This is an important part where b is greater than 0, because we know at some point we're probably going to have to divide by the b, because b doesn't show up in any of the answers. So at one point we're dividing by b because it cancels out, and we can only divide by b if b is not 0. So that's part of why we have to be, why b has to be bigger than 0. We can divide by negatives, but we want to make sure that we know that negative b, negative 1/2 b is definitely in the third quadrant. That's why I do it in the third quadrant. All right. So the problem asks for the 6 trig functions of theta, and we're going to get there through the reference angle. To get the 6 trig functions, we're going to need to know what the hypotenuse is. We can figure out tangent and cotangent without the hypotenuse. We can get tangent and cotangent right now. Tangent of theta is opposites over adjacent. So 1/2 b over 1b. 1/2 of b divided by a b will leave us with a 1/2. So tangent of theta is equal to a 1/2. That one we don't need the hypotenuse for. We can also get cotangent because they want all 6 for some reason. So cotangent of theta, we just have to flip this over, 2 over 1. For sine and cosine, we're going to need to know what the hypotenuse is. So it's a good thing that all of our previous problems reminded us of the Pythagorean theorem. So I'm going to do a 1/2 b squared plus b squared is equal to hypotenuse squared. So the hypotenuse, I spelled h wrong. Now, at this point, we're like, oh, we got to simplify this. At this point, we have to start asking ourselves, do we need the b? So do we need that b? More importantly, why do we not need to write the b in the calculation here? Why is it all going to change the other two by the same amount? What's the phenomenon going on here? Why do we get to do this distributive business? So why is it that instead of using this triangle, yeah, because we have similar triangles, because I'll fix the angle, I don't have to deal with 1/2 b and then 1b up here, and then have whatever the hypotenuse is. I can use a similar triangle where I divide all the sides by b. And figure out that hypotenuse. So rather than using all the ones with a b in it, let's just cancel the b all the way around. Divide everything by b. Now, this one I'm not really a fan of either because of the 1/2. So if we really don't like fractions, we just multiply everything by 2. That won't change any of these angles. That'll be 2 height. That might be too far. The point is that we can get rid of that factor of b if we think it's going to compensate our calculations. So rather than calculating the hypotenuse as the square roots of a half a b squared plus a b squared, we could calculate a hypotenuse as just the square root of a half squared plus a 1 squared. So a half squared is a fourth, 1 squared is a 1. So we'd have the square root of 5 over 4. We could simplify this, take the square root of the top and the square root of the bottom. And the square root of 4 is 2. I just separated the square root. I distributed the radical to the numerator and the denominator. So this is the square root of 5 over the square root of 4. And then I simplified the square root of 4 to be 2. Exponents distribute over products. In the other triangle, in this third triangle, we can find the square root of 1 squared plus 2 squared. And notice that this triangle with 2 hypotenuse, the hypotenuse is just twice as long as the root 5 over 2. Point is, we could use similar triangles to get rid of all that. So sine theta is going to be opposite over hypotenuse, 1 over root 5. We're in the third quadrant and sine is negative in the third quadrant. Cosine is adjacent over hypotenuse, so 2 over root 5, and cosine is negative in the third quadrant. When we look at our selection of answers, we don't find a 1 over root 5 and a 2 over root 5. We only see radicals in the numerator. So then we have to remember, oh yeah, we got to rationalize our denominators. Rationalize our denominators. So we multiply by root 5 over root 5. The only reason that we would be doing this is that we're looking at the answers and all the denominators in our answers are rationalized, then it's multiple choice. Other things that are going on here, sine and cosine are negative in the third quadrant. So that's why I listed those as negative. Any questions? Is everybody okay? Taking a look at the answers, it looks like they did not try to mess with us as far as like signs go, pluses and minuses.
See what else did they do? Wow, they didn't even try to manipulate it. They didn't even let us rule anything out by saying that sine and cosecant aren't reciprocal. Oh, wait, it is. That last one here. We can rule out this last one because it's -2/√3 for sine, and cosecant is not the reciprocal of sine. So that one is out. So one of the things that you can do when you're dealing with a multiple choice type problem, this is not really helpful in learning trig, but it is helpful in doing trig homework, is that sometimes you can rule things out. So for example, we have these 5 choices. And one of the things that I noticed was that sine is √5/5, cosecant is √5. So those are reciprocals. Sine here is 2√5/5. Cosecant is √5/2. So those are reciprocals. So in some cases we have reciprocals. And this third one is right out. Sine is √5/5. Cosecant is not the reciprocal of √5/5. So it is not the third one. And it's also not the last one. We've ruled out 2 just based on the fact that sine and cosecant need to be reciprocals. From a standardized test taking standpoint, we now have to guess. We have put the odds into our favor. It's in our best interest to guess at what the answer is. There are other clues that we might go for. Notice that sine and cosine are all negative in all these choices. So they're not asking this question about, do you recognize what's positive where? Do you recognize that this is the third quadrant, so sine and cosine are both negative? Apparently they assume that you got that. So you're like, all right, thank you, problem. You already understand that I know that sine and cosine are negative in the third quadrant, and tangent is positive in the third quadrant. Because here's sine, they're all negative sines, all negative cosines, all positive tangents. So that's respectful. They're like, oh, you know that already. So we don't have to include that as one of our things. Any questions? Yes. For the on the problem? Yes. So for cosine of theta, we want to do adjacent over hypotenuse. So adjacent is 2 and our hypotenuse is √5. So I did 2/√5 and I marked it negative because we're in the third quadrant and cosine is negative in the third quadrant. And then I rationalized, multiplied by √5/√5 because this problem has no radicals show up in the denominator. So everything's been rationalized. Any questions? That's everybody okay? Everybody looks so tired. It's only week 4.
We have to find one. We have to find the other one.
We have to find the others, but we got a good start. I forgot what the others say, but remember, it says all 6, which really is find all 3 and then flip them over. So sine of theta is -1/5. So cosecant theta is going to be -√5/1. And secant theta will be the reciprocal of cosine. So -√5/2. Okay. This week, we're going to have a round of quizzes on solving triangles. So it's going to be a little bit more direct. There are a couple of word problem quizzes. Remember, in word problems, you don't get to be afraid of word problems. There's a right triangle there somewhere. Draw the right triangle, label what you can label. There's going to be an opposite, adjacent, hypotenuse. It's just a right triangle. There's a right triangle in here somewhere. I just need to start labeling stuff. Once you have a 90-degree angle and 2 other things labeled, then you can find the other 3. That's everybody okay? And as usual with quizzes, you have unlimited number of attempts. So you just keep going. And these ones are graded by Canvas, so you just keep on going until you get full pick.
How's everybody okay? All right, that's gonna do it for today. I will see y'all on Thursday. Everybody have a good couple of days. And thanks for playing.